For this video, we're going to be discussing composition of functions. So to start, we're going to review evaluating functions. So if you remember, evaluating a function is simply taking a function like f of x equals 3x squared plus 5x minus 10 and plugging in a number. In this case, we're going to use negative 3 wherever we see an x. So to do that, what we're going to do, we're simply going to take negative 3. Anywhere we see an x, we're going to plug in negative 3. And we're just going to use order of operations to work this problem out. So first we're going to square our negative 3, so we get 9. Then we can do our multiplying. 3 times 9 is 27. 5 times negative 3 is 15. This negative 10 just gets left alone. And then we can do our subtracting. And 27 minus 15 minus 10 is 2. All right, we can do the same thing with our second problem here. So g of x equals 4x plus 5 over 2x. We're going to plug in 5 anywhere we see an x. And then we're just going to work this out. 4 times 5 is 20. 2 times 5 is 10. Then we're going to do our adding up top. 20 plus 5 is 25. So I get 25 over 20. And that function can be reduced by dividing both the top and bottom by 5, so that we get that g of 5 is 5/4. So that's just a quick review of evaluating functions. Now doing a composition of functions is simply evaluating a function for another function, which is kind of weird, but what basically means is to do the composition of a function, you take one of the functions and plug it into the other one. So the notation looks like this, and it's read as f of g of x. So let's take a look at a couple examples, and this should make some more sense. So we've got these three functions. F of x is 3x plus 2, g of x is x squared plus 4x, and h of x is 5x plus 4 over 3. And we're going to find the composition of these functions. So we're going to find f of g of x. So to do that, what we're going to do is we're going to take g of x and we're going to plug it in to f of x. So what we're going to do is, in f of x, anywhere we see an x, we're going to take our g of x, x squared plus 4x, and that's going to get plugged in instead of x. So here you can see f of x is 3x plus 2, and instead of x, I plugged in the function g of x, x squared plus 4x, in. Now we're just going to use order of operations and simplify this as much as we can. So we can distribute my 3 to start. So I get f of g of x equals 3x squared plus 12x. Okay, and then I don't have any like terms that I can combine. I can't do anything else, so this is my new function, 3x squared plus 12x plus 2. So we just plugged one function into the other one and worked it out. Let's do the same thing here in number 2. We want to find f of h of x. So we're plugging h of x into f of x. So anywhere in f of x that I saw in x, right here, I'm plugging in the function h of x, which is 5x plus 4 over 3. So if we work this out, these 3's cancel. So I've got f of x equals 5x plus 4 plus 2. 4 and 2 are like terms and can be combined to get 6. So f of h of x is 5x plus 6. All right, so we're just plugging one function into the other and simplifying. Okay, so let's take a look at another example, number 3 here. So we're trying to find g of f of x. So we're going to take and we're going to plug f of x, which is 3x plus 2, into g of x, which is x squared plus 4x. So anywhere I see an x, I'm plugging in 3x plus 2. All right, so if I work this out, we got to remember that 3x plus 2 squared is 3x plus 2 times 3x plus 2. And I need to distribute twice here. So when I do that, I get 3x times 3x is 9x squared, 3x times 2 is 6x, 2 times 3x is 6x, 2 times 2 is 4. Over here I just need to distribute out my 4 so that I get 12x plus 8. Now I've got some like terms I can combine. The 9x squared doesn't have any like terms, but I have 6x plus 6x, that's 12x, plus another 12x is 24x, and 4 plus 8 is 12. So g of f of x is 9x squared plus 24x plus 12. All right, if we take a look at number 4, I'm plugging g into h, so it's going to look like this. I'm going to want to distribute out my 5 times my x squared and my 4x. When I do that, I get 5x squared plus 20x, and then I've got my plus 4 at the end. And this fraction actually can't be simplified any further, so this right here, 5x squared plus 20x plus 4 over 3, is my answer. Now down here with numbers 5 and 6, it's a little bit different, because now you can see instead of an x, I've got a number that's getting plugged in. We're going to do these problems slightly different. The first thing I'm going to do for this one, I'm finding f of g of 3. So when I've got a number, what I want to do is I want to take that number, I'm going to kind of work right to left. I'm going to plug 3 into my function g. So I'm finding g of 3. So that's 3 squared plus 4 times 3. 3 squared is 9, 4 times 3 is 12, so that's 21. And now I'm going to take that answer, 21, and I'm going to plug that in for f. So now I'm going to do f of 21, which is 3 times 21 plus 2. 3 times 21 is 63, and 63 plus 2 is 65. So my final answer of f of g of 3 is going to be 65. So I work right to left. I plug my number into my first function, and then I plug my answer from that into my second function. Let's do the same thing for number 6. I'm finding h of f of negative 2. So I'm going to plug negative 2 into the function f. So that's f of negative 2 is 3 times negative 2 plus 2. 3 times negative 2 is negative 6. Negative 6 plus 2 is negative 4. Now I'm going to take this negative 4, I'm going to plug that into h. So h of negative 4 is 5 times negative 4, and this should be divided by 3. So 5 times negative 4 is negative 20. Negative 24 plus 4, or negative 20 plus 4 is negative 16. And negative 16 over 3 does not reduce, so that is our answer. So I'm going to leave you with 2 problems here. These should say numbers 7 and 8. All right, as your try-it problems for tonight. So I want you to find g of h of 6 and f of h of negative 4. So you're just going to take 6, plug it into h, get an answer, take your answer from that, plug it into g, and that'll be your final answer. Do the same thing in number 8.